did not expect this turnout, although I literally can't see anybody. I can see a couple of shirts, but I feel the pressure, to say the least. Welcome to this session. My name is Bozidar. I am tremendously honored, and thanks to What the Stack, thanks to Darko, for giving me the chance for a second time to be the first speaker. We also, together with Reko, did the first workshop of this first conference. So many wows for me on this one, really humble. What are we going to talk about today? I will not be speaking about things you don't know. So everything here today is history repeating itself, and I'm sure that everybody knows what we're going to talk about and has seen, and yet nobody likes to think about it. So here I am trying to remind everyone that we can be hacked with our own credentials. So simply, attackers, our hackers, whoever, whether malicious, whether just activists or plain criminals or malicious employees, whoever they are, they have to get it right only once. They can try infinite amount of times, they only have to get it right once in order to compromise us. We need to get it right all the time. So let's make sure to make the effort to get it right more often. Software development, as I see it, maybe I'm wrong, and I welcome everybody for comments or objections to this one, but it is all about delivery. It is producing something, and obviously while salary is provided to us, we code, we deploy, we invoice, hopefully we have a happy customer. The entire philosophy is wrapped around the approach of it's okay to make a mistake, it's fine. We're going to fix it in the next sprint. We have time to think about it. There is a bug, but it's not that big a deal. The code is private, so we can take our time and consider it, and that is the way we have always done it, so it must be the good way. And I'm not here to object that this is a bad way of doing things. I'm just going to object to saying it's okay to make all kinds of mistakes. There are things that we should push ourselves to have more discipline on. Again, to the hackers, because I've been working on the platform Beyond Machines as a platform now for nearly a year and a half, collating data, a huge amount of work and parsing. I can tell you, hackers are mostly not that smart. They are using a lot of very simple mistakes created by one of us. I'm, for this purpose, considering to be part of the development process, not part of somebody just sitting on the sidelines and bitching about this. But because hackers don't need to be very smart. There is a bunch of automation. Every single vulnerability that is out there, or very serious vulnerability, has already a POC, a proof of concept code, created by someone like you, just to show that there is a problem. However, that makes it terrifyingly easy for a malicious attacker to just take the POC, make a couple of small changes, and run it at scale. And they will run it at scale. They don't care whether they are running it against me, or against Blue Dot, or against Google, or against whoever. They don't care, really. Just a couple of days, Transport for London, the company that manages the metro and the buses of London, was hacked by a 17-year-old kid. So they don't care. It's fun. It may be profitable, but really, they are attacking at scale. So you may not be specifically targeted, but you will be compromised. And one other thing, maybe somebody can explain to me, why is $1 times million times much larger than $1 million once? Has anybody asked you, or arrested you, or arrested anybody really, for stealing $1 from anyone? It's fine, you lost it, we don't care. Time it a million times, suddenly you have $1 million. And nobody's that disgruntled or angry or even surprised. Steal $1 million all at once, police knocks on your door. And that's where hackers also profit. So they're going to do it at scale. They're not going to profit infinitely from you as individuals, but they're going to take you for $6 or $5. And you're going to get hurt, but you won't even have an argument to go to the authorities. There is no protection for you because, fuck it, $5. So it's up to us to make less mistakes. And that's why we're here today. When something happens, it is always you three. The DB name, the DB user, and the DB password. Yep. And they are intentionally not properly masked just to show you what really happens in our life, in our reality. And we always assume that somebody is going to fix it, somebody else. Because I was doing it as we are always doing it, as it was done forever and again in times of immemorial. And I'm thinking that somebody in the next team, or somebody in the previous team, or somebody in the project just across to the other room is going to fix it. And they're also thinking that we are going to fix it, or I'm going to fix it. And all that comes down to this little diagram on the left called the Swiss cheese failure model. Slices of cheese, if you align the holes one behind the other, the vulnerability passes through. An active failure passes through all the barriers because all the holes in all the barriers have aligned, and suddenly we have a failure, or a hack, or a breach, or a data theft. So assuming that somebody else will do it doesn't work, because they are also assuming that you will do it, and nobody does it. So who am I? A lot of introductions, so I'm not going to repeat myself. I'm just going to tell you, I tell people what not to do. Sometimes they listen. In this session, in this conference, we're together with my dear friend Veko as Dev versus CISO, and as you can see, or you can try to guess which one of us, Veko is there, right there, and you can guess who of us is the Dev and who of us is the CISO. And yes, I do go to work like this. If somebody wanted to ask that question.
Me too.
No, he doesn't. He has shorts and he wears slippers.
Yeah. It's getting cold.
Of course. So the root lawyer function needs to be invoked now to just tell you that all examples, concepts, and code in these sessions are for educational purposes. Use this knowledge for good. So this is me being the Jedi Master. Do not go to the dark side. Any information or techniques used are for illegal and harmful purposes are illegal. Please don't do that. We're not responsible for any misuse, obviously, as I said. If we had lawyers, this would be something that our lawyers would have written. So, what we are going to be talking today is how we store our secrets, credentials, API keys, passwords, database keys, everything and anything. Can anybody maybe tell me what this symbol is? The heart, the X, and the box with eyes.
Love the robot.
Exactly. Thank you. There was a wonderful. I'm a fan of illustration and comics and anime. So this particular episode with the mechanical fox that is hunting was really hitting the right note for this session. So we are going to go hunting, just like that mechanical fox went hunting. So, let's start hunting. First, let's be the developer. Let's do a simple mistake that can go a long way. And we're going to do this with our current code, which is this very special. I hope you can see it. Okay, so we have this very super secret Python, which has a screamingly obvious mistake. I'm going to explain it because it is literally screamingly obvious. And what we are going to do is we're going to add it to our source code, to our repository. Sorry. Done. It's up in the cloud. It's on the internet. And I would say, but it's fine. The repository is private. Why do we care? Nobody's going to see our repository because obviously somebody else is taking care of this. There is a DevOps team or an architect or whoever is in charge of the entire process that says, oh, but this is a private repo, so all this is fine. But somewhere somebody else decides that your brilliant code is just brilliant enough to make it public, to make it available for the whole world to see, because it is important and it is valuable and people can benefit from it, really. And I have been part of that conversation multiple times. A dear colleague of mine from the previous company is probably in the audience, at least I'm hoping he is, that we had this discussion, do we go open source with this? And we had said yes, without even checking whether something like this existed in the code. So let's do our mistake right now, because this is a mistake that can really happen. We are going to make this public. It's obviously going to ask me for a bunch of passwords now, so bear with me. Done. We made one hole and we pushed the vulnerability through, and now we made another hole and we pushed the vulnerability through. Is there anything else protecting us right now? We can only hope. But going back to our discussion, some of you may say, okay, you just constructed this to be perfectly aligned. Nothing like that happens ever in real life. Except hacked employees do happen. Leaked SSH keys, and this is in reverse sequence of probability. Leaked SSH keys by whatever function, whether it's just somebody replaces a laptop with somebody else and finds the SSH keys, or somebody does a copy-paste somewhere, or just zips it, an entire folder with the SSH keys and sends it somewhere else. It can happen. Blog posts and presentations. I don't know if you're aware that the Chinese government had a data leak of over 1 billion because one of the developers of their software made a blog post about his brilliant code. And in the blog post, he posted screenshots of the code, including the keys. I kid you not, find it. Changpeng Zhao, CZ of Bit, help me out. He is. Nobody knows where he is, but that Chinese guy from the platform posted literally a day after that breach happened that their internal team found the blog post. So yeah, that blog post existed. Logs. Everything and anything goes into logs. We all love to debug and to find things in logs because we need them. And lo and behold, a lot of them, just go back to your logs, go back to your application, go back to the whatever central logging system you have, go back to the pods, to the servers, to the standard output and see what is printed out. And I bet you will see either clear text passwords or JWT tokens or whatever tokens you're using, including keys like this. And obviously what I did, let's make this open source. And I'm going to slip one more because somebody says, I will not be hacked. This is an actual hack initiated through GitHub. I don't know if you can read it, but it says literally somebody managed to successfully impersonate GitHub HR and sent this out to a bunch of developers through impersonating GitHub, even sending from notifications at github.com. Find me later, I'll explain it in detail if somebody wants. How that worked. And people received this. And they had to click on that, please click here to access forms, blah, blah, blah. If they did click, they would be led to an app requesting permissions to their code. The permissions are there on the right. So they can delete repositories, read and write access to gists, Organizations and teams read only, repositories access private and public, discussions at the very bottom, it's not visible there. And again, find me later, I'll explain this in detail, but I am aware of multiple people who accepted these permissions to that app. So yes, it does happen, yes, it has happened. I hope none in this room were part of this exercise, because statistically someone would have clicked. And finally, I'm going to go back. So now we had a mistake. Oh my God, let's fix it, it's in GitHub. Veko, would you like to tell them that GitHub never forgets?
Yep.
GitHub never forgets. And I'm going to show it to you now, that GitHub never forgets. So let's go to just ask GitHub these questions. This one simple question. I asked GitHub to find me a string called removed API key. And I found pull requests, 2.7 million of them. When people found out that they have entered an API key, they made a pull request to remove it. And this is how things look. Files changed. So if you ever find yourself that your API key is leaked, it is gone. You don't fix it. Veko can try to explain how to delete it, but even GitHub tells you if it is in our repositories, you are fucked. Disable that key, remove that key, break that lock. Don't try to hide the key. It's gone. It's already gone. So, coming back, simple mistakes go a long way. I think that was enough for just pure GitHub rant. I'm going to switch to containers. We're fine now because we're going to be working with containers and everything in the container is magically perfect. So let's build a container here, just for us. So we have this Docker file. And again, the Docker file, somebody managed to do something unfortunate. And we're going to build that Docker file. And it's running now. While it's running, and all these commands that I'm showing to you are going to be part of the repo that you are going to be able to see later because we made it public. And yes, the keys will be useless by then. So, running it now, because we run it, and then we find it in a separate terminal. We find my secret app here, and we do this. We export this, because this is important for everybody that doesn't understand. Once a machine is running in Docker, essentially it can be exported into a tar file. And if we open that tar file, so here is that tar file. I don't know if it's visible. I can't even expand it anymore. But exploding that tar file gives us a folder. And in that folder, there is a folder called app. And in that folder, there is a Docker file. And in that Docker file, there is everything that we just dumped, including our secrets. So sequence of events. Somebody builds a Docker file, somebody pushes it to a central Docker repository, whatever your Docker repository is. Whether you yourself use it, whether somebody else uses it, whether the entire world is able to use it because you made it public, your Docker contains your secrets. And this is all because of copy./app. We copy everything. That is the first instruction that we do in Docker. And another thing that everybody forgets to do is manage their Docker ignore. Just like git ignore, there is a Docker ignore. Here it is there is a Docker ignore, but it's fully commented out. So Docker ignore is ignored. And finally, nobody will see this in production. Whatever we did, it is magically invisible, but it is running live on the internet. Source code included in build and deployment. Has anybody any conception that this is even possible? Show of hands. I can't see, I see very few hands, maybe it's my eyes, but let's try it. Let's really try it. So we're going to back to our README, and we're going to ask Google this little thing. Here we go. Can you really see it? .git in title index of. Hello. Scrolling down, scrolling down, scrolling down. Hello. Anybody know these guys? Scrolling down. This was not intentional. This is essentially what Google gave us. As you can see, there are thousands of them. So what can we do? So let's click on one of them. Let's see this BCS, whatever. So what's in there? Okay, good. These guys fixed it. High Street Consulting, whatever. It's the entire code. So what the fuck? Let's see. Back to our magical machine here, and we do this. So we go to our code here, and we say git dumper, and our file, and just this, whatever, High Street Consulting, enter. Fetching. It is just pulling the entire code back into a GitHub repo. It's going to take some time. I'm actually not sure how much time, because some of these repos are huge. We can find something smaller, but essentially what it will do is it will pull back the entire source code, convert it to a .git, convert it to a GitHub repository on our local computer, and we can use it, we can search it just like we are doing this so far. So while we are running this, great. It just finished just in time. And there is this little magical program called Git Leaks. I urge you to install it, I urge you to use it, and we're going to ask detect -v. Great, no leaks found, successful. Let's see something else that I tried earlier. So there is this securityknowledgeframework.org, which I found before this session, and I'm going to try the very same command. Things are not that great here. This is a live site with their live data and their securityknowledgeframework.org. Should we try this on Brainstorm?
Yes.
We don't have enough time. Later, in the question session. Okay, so let's go back. We have a little bit more scary stuff. So, people, even if it's not browsable and indexed immediately, it's fuzzable. So you can just make a forced browser. I don't know how many of you here tried our challenge before the session, before the conference. Anybody? Great. So some of you did. There was somebody, which I can't say who, that actually employed a cannon to kill a fly. They employed the machine, a program called GoBuster. They were fuzzing the site. They were trying to find everything on it. So you just run GoBuster on this for .git, and you will find these things easily. So if it is out there, it will be found. Let's go back to our AWS key at the start. The first mistake I did was I created a commit with a real AWS key, and then I sent it to GitHub, and then I opened up that repository. So for our exercise, I'm going to do something else now. I'm going to go to AWS console. And, oh, okay, I'm not even logged in, so this may take a while. While that happens, I'm going to show you an email which I received a couple of minutes ago. And bam, action required. Your AWS access key is exposed. Because this was a real life access key. Limited permissions, real life access key. AWS already panics. His account, etc., etc. And they have created an urgent support case immediately. So fortunately for everyone, us, we are being helped by AWS, and Google does the same for their own keys only. They don't care about the rest of the keys. But for their keys, they will do their level best to help us. And they will now also reduce the capabilities of this key. But sometimes this may not happen. Sometimes it may be too late. As somebody mentioned in the audience, suddenly my bill may be exponentially larger because somebody is already crypto mining on my instance. Several hundreds of thousands of dollars are in. So this is what happens. And then you go in, and then you see something like attempts at login, attempts to validate, attempts to create a new user. This is the reality of things when we commit real AWS keys. It took, so this email was received 11 minutes ago. We started this session maybe 15, 17 minutes ago. It takes four minutes between deployment and first detection, whether it's AWS, whether it's an attacker. They're all using the same crawlers. So somebody else already knows this, and somebody else is trying to validate whether it's real, and maybe somebody's trying to even earn money or sell it. As I said, $1 at a time, not a million. $1 from me, $1 from you, $1 from somebody else. So coming back to our presentation, they have to get it right only once. We need to get it right all the time. So make the effort to get it right more. How to be better? In the same README that I'm just showing you, there is an entire instruction set on how to implement pre-commit hooks, which will essentially create a control, which will create a script. Every time you try to push something into remote, it will stop you, it will run git leaks. If it finds any kind of secret, it will kill the push. It will stop you, dead. And it's better to stop you then than to try to do a pull request trying to delete the key, which we saw that doesn't work. Docker ignore and git ignore are your very best friends. Use them liberally because they do help a lot. .env files, part of this repo here, has an env file. I'm sure most of you know it's an environment file to load various things. Again, keys. If I do the very, let's call it common, I'm going to refrain from calling it stupid, git add dot, everything goes, including the .env. Git okay, something is not right, but okay, maybe. Essentially, that is what will happen. So, Docker ignore, git ignore are your friends. Use roles where possible, not API keys. This is for cloud implementations. And keep secrets only in vaults, in vaults or parameter stores. So when you invoke them as an external variable, never hard code them. If you're looking in local environment, put that environment file in a separate folder. Make triple sure that it is in the git ignore file and in the docker ignore file and in anything else that you can, and then have pre-commit hooks. And if you think that this story is not scary enough, there is entire research linked here. This presentation is going to be available to you for an effort that was just completed, and I have a story about that. The guy was fired from his work from his job at CrowdStrike because they tried to stop him from publishing it. This went on to Black Hat this year, or DEF CON, some of those, and they had found thousands. So they looked through AWS AMIs, the built-up machines, so equivalents to our Docker images. They searched thousands of them. They found hundreds of thousands of keys in public AMIs. You can read in details here. It is scary enough without them, I think. So with just 4 minutes and 32 seconds over time, I'm handing it over for questions.
So, due to our time constraints, we only have a space for one question, so raise your hand. Any questions? Okay, with that, I would like to have one big round of applause for Bozidar. And I hope